How do metals and non-metals react? In the previous class, we have seen that noble gases like helium, neon, argon have completely filled valence shell and therefore they are stable. Metals like sodium, magnesium, aluminium, potassium, calcium have 1, 2 or 3 electrons in the outermost shell. So they have a tendency to lose electrons. By losing these electrons, metals can get stable octet configuration in the outermost shell. Since metals have a tendency to lose electrons, they are said to be electropositive. By losing electrons, metals acquire a positive charge. Metal atom changes into a cation. Similarly, non-metals like nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine have 5, 6 or 7 electrons in the outermost shell. So they have a tendency to gain electrons. By gaining electrons, non-metals can get stable octet configuration in the outermost shell. Since non-metals have a tendency to gain electrons, they are said to be electronegative. By gaining electrons, non-metals acquire a negative charge. Non-metal atom changes into an anion. So let us now learn how the metal sodium reacts with the non-metal chlorine to form sodium chloride. Formation of sodium chloride. Sodium atom, atomic number 11. So write the electronic configuration as KLm281. Sodium has 1 electron in its outermost shell. So start with sodium atom 281 configuration. 1 electron will be lost by sodium and sodium thus changes to sodium ion Na+, the configuration changes to 28. Chlorine atomic number 17, electronic configuration KLm287. Since 7 electrons are present in the outermost shell, chlorine requires 1 more electron to get octet configuration. So 1 electron lost by sodium will be now gained by chlorine, changes to chloride ion with configuration 288. Sodium with 1 electron plus chlorine with 7 valence electrons. This is the Lewis representation. 1 electron will be transferred from sodium to chlorine. Since 1 electron is lost by sodium, it becomes Na+, and 1 electron has been gained by chlorine atom. Therefore, it changes to chloride ion. Thus, we get sodium chloride NaCl. Formation of magnesium oxide. Magnesium atomic number 12. Electronic configuration KLm282. Magnesium has 2 electrons in its outermost shell. So start with magnesium atom 282 configuration. 2 electrons are lost by magnesium. So magnesium changes to Mg2+. 2 electrons are lost. The configuration of Mg2+ is 28. Oxygen atomic number 8, electronic configuration Kl26. So start with the oxygen atom 26 configuration. Oxygen atom requires 2 more electrons. The 2 electrons lost by magnesium will be now gained by oxygen atom, and thus oxygen forms oxide ion O2- configuration 28. Lewis representation, magnesium 2 valence electrons, oxygen 6 valence electrons. There will be transfer of 2 electrons from magnesium to oxygen. Since 2 electrons are lost by magnesium, it will be Mg2+. 2 electrons are gained by oxygen, so oxygen changes to O2-. 2-. Thus we get magnesium oxide. Formation of sodium oxide Na2O. Sodium atomic number 11, electronic configuration KLm281. So start with the sodium atom, electronic configuration 281. When sodium atom loses 1 electron, it changes to sodium ion Na+. The configuration changes to 28. Oxygen atomic number 8, electronic configuration 26. Since 6 electrons are present in the outermost shell, it requires 2 more electrons to get octet configuration. So when oxygen gains 2 electrons, it changes to oxide ion O2- configuration 28. Lewis representation. Start with 2 sodium atoms, 1 valence electron each. Oxygen 6 valence electrons. Each sodium atom transfers 1 electron to oxygen atom. 1 electron is transferred from each sodium, so it is Na plus, but 2 such ions are produced. Since 2 electrons are gained by oxygen, it is O2 minus, sodium oxide.